look, it's me, John Park, and we're here for John Park's workshop. That was a nearly flawless transition. Not really, I had a little bit of echo there. Welcome to the workshop, all of you good people here in Discord land, YouTube, Facebook, Twitch, where else are we? Periscope on Twitter. Oh, you know what? Northern Pike, the HalloWing was in stock this morning. And the reason I know is that I actually set up an alert. If you go there and click on the notify me, you will get an email as soon as the HalloWing is in stock. So that's a pro tip for you there. And then you can order it. Hey, we've got a really good show in store today. I know I say that every week, but I also always mean it. So let's see. I want to start off with our coupon code. So in case you get a notification for something that was out of stock that you want to get, or you decide to get something else different, here's your coupon code for the day. And that coupon code is... That's right, the coupon code is... And that's spelled M-W-O-W-M. That's a lightsaber noise, I decided. I actually looked it up. There's an article, a fairly recent article about how do you spell the various lightsaber noises. And a lot of people debate this. The person writing the article got the advice of a linguist, and the linguist said actually most of our phonetic spelling stuff is made for phonetic spellings of human languages, not sound effects. So there was no definitive answer. But that's my attempt at one of the lightsaber noises. So 10% off in the store with the coupon code and that's good for anything you can get in the store other than gift certificates, subscriptions, and software. And that's going to bring us right up to the product of the week. And the product of the week, there's a little sneak peek actually. The product of the week is right behind me. It's that thing right there. It is the Featherwing for RGB Matrices. This is a 32 by 32 pixel, 4mm pitch matrix. So let me not hide it with that thing. And the cool thing about this one is that it's got, if I can get my cable, I've got power running up there. It's got this feather running it right there. So this Featherwing allows you to use an M0 or an M4 feather, and it is designed so that it just sort of backpacks onto these matrices. So we have 16 by 32, 32 by 32, and 64 by 32 that this will run. And so these are not NeoPixels, but these are RGB LEDs, and these little panels are actually what giant billboard displays are made from. So if you've ever wondered what's in a baseball stadium or a video billboard, it's these guys, just tons and tons of these guys hooked up to each other. So the Featherwing itself, I can pop this off of here. Let me pull the power first. The Featherwing itself has a little connector that pops right into the back of the matrix, and then a wing, or rather a feather, can go on top of it. This is one configuration, and that handles the power. So I'm going to pop this back into here, and it just programs, I'm programming it with an Arduino sketch, and I made a little sine wave table, which is what this is playing back here, and you can adjust the colors and stuff, with hopes of doing something reactive. I kind of want to do a sound reactive FFT kind of thing, or somehow integrate this into music. For those of you that are into this sort of thing, these panels, the 4mm pitch 32 by 32, are sized the proper dimensions to fit in a 3U Eurorack modular synthesizer case. So I kind of have, I like that. Got some ideas of hooking that into the Eurorack. Be kind of cool. So that's product of the week, and that is product ID number 3036. So head to Adafruit and check that out, that little RGB Matrix Featherwing. Super cool. All right, well, let's see. Yannick says he made a clock with one of these using the Raspberry Pi hat. Very cool. Memory on this is enough to do some simple stuff for sure. I know if you want to get fancier, you may want to look at the Raspberry Pi and ways of connecting those to those. And also I think you can go to the larger displays that way. But I've never had one of these. I've never used one of these before, and I'm very excited about the way it looks. It's kind of cool. Let me know if that's distracting back there, but I think I'm just going to leave it. It's kind of fun. All right, well, let's see. Are we ready for... I think we're ready for the Make Code Minute. Let's hit it. That's right. It's the Make Code Minute. So let's pop up our... There we go. There we've got our little display today. So what I want to talk about today, this is my little ice cube prop, is sensing temperature with the Circuit Playground Express in Make Code. So the Circuit Playground Express has a little thermometer built on. You'll see there's this little silk screen right here of a little thermometer symbol. And in Make Code, what I've done is gone ahead and brought in some blocks, or some extra blocks here that I'm using to show this little display. This is the Chibi scope. You don't need that to do this though. So ignore these serial blocks. And all we really need to do is I'm setting the temperature variable that I created to be the temperature in Fahrenheit that is being sampled off of the board. And then I have a simple if-then statement. I say if that temperature value is less than 84 degrees, then I'm going to consider that cold because it's kind of hot here in Southern California. So 84, that would be cold, and we'll set the pixels to blue. Otherwise, if the temperature is equal to or higher than 84, that's what this else statement takes care of, it's going to set the pixels to red. So you can see right now they're red, and what I'm going to do is I have a little ice cube. Let's see, this is already starting to melt out here, but if I can get my finger cold enough, or I can set this directly on there, but I think I'll get my finger cold enough when I set this onto the, oh gosh, we're right at 84. All right, let's set this on here, see if we can get it. Ah, there we go, we're blue, so 78, oh, and we're back up to red again. So it's pretty responsive, as you can tell, and we can read the temperatures there. So that is how you can read the temperature on the Circuit Playground Express using Make Code. There, I did the music. I know someone said in the chat that we should have some music with that, and you're right. I thought I had one attached to it, but I add those in later when I post those up on YouTube. So, yeah, going back to this actually for a second, this is the after the minute. This Chibi scope, I mentioned this on Show and Tell yesterday. This is a super great little scope, and it comes in this cute plastic case, and it uses alligator clips to connect it to things, but I decided to sort of semi-permanently attach it to the Circuit Playground Express using standoffs. So these are the brass standoffs that we have for the Cricket boards. And you can see I've got power and data running to the serial TX pin with these alligator clips. And then I've got ground directly connected to ground on the board. So that gives me a little display that I can kind of rely on having there. If you, oh gosh, is Thanos back there? Who said that? So if I hit this little button on the top of the Chibi scope, we can go to reading voltage, or we can go to a graph. I think that's graphing what's coming over TX, right? That should be. So these are my temperature readings. Let's see if it changes. I don't think it's going to change, is it? You going to change? Am I not getting it cold enough? Yeah, that data is not easy to read that way. That's not what it was designed for. But yeah, you can see the change there. I think that's the serial data that's running across that, which is kind of a weird use of it. But anyway, I thought that was a fun little hack with these Chibi scopes. I love these things. So that was the after the minute, after the Make Code minute. Hey, Summersoft noticed in my Ultimaker, I have a The Max action figure. I just found that in a box the other day. So remember that comic? I decided to set him in there because I didn't have anything printing. All right, well, hey, let's now move on to our project of the week. So the project of the week, I'll show you a little teaser video here first. Okay, and I show you that teaser video just because it's going to be a little trickier to control lighting in the workshop here, and I had turned my settings on the camera for capturing that the other day and recorded it. So what we're making is a lightsaber. I've made a couple of them using the HalloWing as our mother or our microcontroller and sort of peripheral board. So what this HalloWing is controlling on here is a strip of NeoPixels running up through the blade. So we have a NeoPixel output that we just plug this strip into directly. I'll show you these parts separately in a second. I've got a little speaker, and that's plugged in down here into our little speaker port. And there's the speaker. I've just sort of stuck it. These speakers come with a little adhesive, so I've stuck it to the side of the lightsaber. And then power. I have a LiPo battery in here. This is a $9 toy store lightsaber that I've kind of hacked the blade off and added my own. And I'm going to show you in a minute what I'm using for the tube and the diffusers and holding the NeoPixels in there, because that's really half the battle, is just getting things straight and nicely diffused in here. And then I've just attached the HalloWing to the side using some double stick tape, or you could use some zip ties for that. So let's power this up. So the way I've mounted it on here, I still have access to the on-off switch, the capacitive touch sensors, and the USB port for programming. And the program on here is something that Phil B. wrote in Circuit Python. So I'm going to turn this on. Okay, when it's on, we get just a little indicator, the onboard NeoPixel, but it doesn't do anything until we touch this, this pad here. Okay, so this one, you can hear this, this is the unicorn version. And I'm going to go and display this in the dark for you in a second, but let's put that one away, and I'll demo that more. So I've got a couple of versions that are going to be in the guide, and it's up to you to build anything you want with it. Yeah, so Matambale said, nice, your own soundtrack, right? So unless that's an old comment and you're talking about my Make Code Minute. But soundtrack for this sword, what we've done is we've created a number of wave files that represent, I think, 5 or 6 different things that the sword can do. And just by overwriting those wave files and naming them what you want, you can change the behavior of the sword. So why don't we switch over to, I've set up kind of a little, you see my little fort here. This is the teepee of darkness, or the tent of darkness. So let me go over to the main camera here, and let's do the overhead like so. There we go. Okay, so I just set up a couple of pieces of foam core so that we can go from, you can see my face right now, this is the sort of light level in my shop, and it gets pretty dark inside of here, also kind of echoey. And from the overhead camera in the corner there, you can't see too much now, but let's go ahead and turn on the sword. So I've got the idle sound, which is angels singing. A lot of people don't know this, but Darth Vader is a Brony. Okay, so let's power this up again. And now when I wave it, oh, there we go. I'm gonna whack the tent. So I don't know if you can hear that. Let me move that a little closer. So we've got a hit animation and sound. I'm going to whack the... All right, so that's when we hit something, and that's when we swing it. There we go. It's a little better demo. And that puts it away. And while we're at it, I'm just going to fire up my chat machine over here. I'm going to... let's see if we can get this thing to refresh. I'm going to show you the other... Boy, this thing always turns the audio back on. Stop. There we go. I'm going to demo the other one, and then I'm going to show you the physical differences in these swords. So this is the same circuit setup and very similar software, but... you should be able to hear that. And then when we hit, there we go. So I'm going to take these away for a moment, and we can get a better look at how these are built. So you may remember, actually I have it sort of back behind in some storage over there. You may remember I made a sort of insane lightsaber, a display one, really not for moving around, that was made from a fluorescent bulb that I cut the ends off of and put NeoPixels inside of and made a handle for it. Super dangerous, don't do it that way. It was made of glass, it was just meant to look cool on the wall. These are plastic, so let's talk about the parts. So the first thing is, and I don't have an intact one anymore, but this is the closest we're going to come to it. So this is a bulb tube, what do you call it, bulb guard or tube guard, and normally this is 4 feet long. I cut it in half. This costs about $4 at almost any hardware store, or you can buy them online for about $2 a piece. I'm not sure about shipping. What these are made for is anywhere where you have a lot of fluorescent bulbs that you want to protect from getting smashed if someone flings something into them. So these are a polycarbonate tube that have open ends on them, and there's little plugs that come off. And these open ends, you slide a T8 4-foot long, and I think they also come in 3-foot long fluorescent bulb, and then hook it into your ballast and housing as normal. So I thought these would make potentially a good tube for doing a lightsaber, and it turns out they're fantastic. So that's my first tip, is look for bulb guards or tube guards. Really great for this. Next thing I did is I tried out diffusing them in different ways. So here you might be able to tell I took some sandpaper inside here to scratch it up and see if I could get some diffusion. It did not work very well. Another thing I actually tried this on a plastic cup, is spray painting the cup white. And this may work well, but I was using Plastidip, and so it was very uneven. I think if you use just normal white spray paint, it may make a very good diffuser. You're doing about 3 feet or so, maybe 2 feet of plastic, so you may get even coverage, you may not. But what I noticed is the coverage was pretty uneven here, so the jury is out on this technique. You may also want to try, I didn't try this, pouring some thinned down acrylic paint and turning it and swooshing it until the thing dries off. Maybe you could build yourself a little rig that does this kind of stuff to get a nice even coating. But what I tried instead next was some different kinds of paper. So I tried tissue paper, I tried wax paper, and then what I ultimately settled on is parchment paper. So parchment paper for baking is a really terrific diffuser in this case. So what I did was just pulled off a roll or a section of it that was as long as the tube, and then that'll give you more than enough width to roll this over a few times, which improves your diffusion. Yeah, wax paper, John. Wax paper worked pretty well also. It diffused very nicely. It was just a little harder to handle, a little harder to deal with. It kind of wanted to crumple, and the parchment paper just seemed a little bit stiffer and a little easier to work with. So took that and, as you can imagine, rolled it up tight enough to fit inside the tube like that. This is not sized for this little remnant tube here, but you can get the picture. And let's see, let me demo this. So here's another strip. So these are the strips I'm working with. These are 60 LEDs per meter, and this is a half-meter long strip. Of course, you could go with a longer strip and a longer sword if you want. And these terminate in these little JST plugs meant for our HalloWing. So I'm going to pull out the connection on this. Whoop, let me turn it off. Get your hand cut off with these things. So let's see. There we go. Multiple light coats of paint is the key, says Summersoft. Excellent. Good advice. By the way, these tube guards also come in colors. I didn't want to do that because I'm using NeoPixels here, but you may get a more saturated color if you have a single color in mind and just want to light up white using full color on the LEDs. So here we go. I'm going to turn this on. So you can see already, actually I'm going to stay. I'm going to try to put the tent back up here, and let's go to this view real big. So I'll show you the main thing, and if you've ever tried to do this sort of thing before, you'll no doubt have encountered the main issue with doing these sorts of things is keeping the hot spots of the LEDs from showing up. And so if they touch the tube or get too close to the tube, you'll see these hot spots. So here you can see if the, whoa, there we go. If the LEDs are close to this edge, we get a lot of hot spots. And so this was my next, I went through a couple of different ideas. I had attached the NeoPixels to a dowel. It's like a 7/16 dowel from the hardware store for a couple bucks. It worked okay, but I still was having problems with it leaning. At the very top of the stick, it kind of wanted to lean. And so what I came up with is using Coroplast. I'm going to turn the, let's see if I can unplug this speaker from here. There. So corrugated plastic. It actually acts as a bit of an early diffusion in this case. You can see it spreads the light out a little bit. But more importantly, if you sandwich the LEDs in a couple layers, and do I still have one that I've cut? I don't think so. I'm just going to take this little remnant. So if you take Coroplast and make a little sandwich out of it, I cut these out of a big Coroplast sheet to be just a little bit under the inside diameter to account for thickness of my tube. And so if I remove the diffuser for a second here, you can see what this does is it holds it at a pretty precise spot that's basically in the middle of the tube without needing some extra supports up at the top. It's going to be really nicely wedged in there. And if you get the width too much, you'll get an oval sword. So you got to kind of experiment with getting the width just right. I think it was just about an inch. And then if I show you inserting that into the parchment paper, let's try the other end. I think the other end is a little nicer. I didn't roll this very well. What I actually, I'll show you the full thing. What I did was I used just some Scotch tape to tighten that Coroplast sandwich a little bit. I put maybe 5 strips of tape going down the length of it, so that's held in there nicely. And I'm going to get that in there. And now you can see the hot spots have gone away. Maybe I can hold my hands there. You can see that I've wrinkled this a little bit so it's not quite even. But if you look at these swords, so I'm going to switch back over now. Now you know how that's put together. And actually, I think I'll pull this sword apart in a second and show you everything there is to know about the assembly. Come on. JST connectors really like to go in, but they hate to come out. In fact, I'll show you something I often do is grab some needle nose pliers and pull it out carefully from the sides. You don't ever want to pull on the wires. You're definitely going to end up yanking the wires out of the housing if you aren't careful. Oh gosh, come on out. Holy cow, this is a tight fit on here. These are terrible pliers. Let me get some that actually have a little grip on them. Come on. There we go. Jeez Louise. All right, let me set this one off to the side. So let's pull this the rest of the way apart. So you can see, zoom in a little bit, and see what this is all built from. So I've got the tube that we just mentioned. Oh, look at that. Let me go to a, here we go, hello. And then the tube, if I pull it out, you'll see, is, I've got everything here other than, you can see I've taken the speaker out of there. But I've got everything inside the tube, so there's my battery, and there's my NeoPixel strip up in there. And then what this is another piece of coroplast. I happen to use black in this case. So there's a piece of coroplast. This is the stuff you'll see like politicians sticking their signs in the lawn. That's what that stuff is. It's really great material. It's very similar to corrugated cardboard. And just like corrugated cardboard, you can go ahead and slit it with an X-Acto knife to create flexible sections. So if I just run in between every flute here, you'll see you get a nice tank tread style. Here's one that I've done before. There. So I took a section like this and just wrapped it around the tube so that it would fit nicely into the handle I'm using here. You can see I also decorated with this stuff. So that's coroplast, and then I colored in every other one of these sections with a liquid chrome pen. This is a Molotow pen. These things are awesome. And that's what I used to get this nice chrome effect on here. So it's really nice for adding some style and pizzazz to your builds. And then what this thing is underneath here is a sink drain extender from the hardware store for, I think, less than $4. So that's meant to connect to your sink, and I thought it would make a nice lightsaber handle, and really all I had to do to make it work here was adapt the tube diameter using this coroplast. And so depending on the size you get, this is a 1.5 inch drain extension that I'm using, 12 inches long, and they come in different lengths as well. So that is the secret of that build, and that's one of the ones I'm going to be showing in the guide. And then I've also got the lightsaber handle here. So this is the spare one I got in case I needed it. So this is a telescoping toy one, and all I did on this one so that I could fit the tube down inside just like before is sawed off the little tube and left just the largest diameter section in there to set this tube on top of. So let's see if I can pull that out there without breaking anything. You'll see there's just a little bit of that red base tube in there and enough space for my battery. Got a little LiPo battery in there. And then that just slides into there. So you don't want to fling this too hard, or you might want to tape this or use some other material to prevent that from moving around in there. So you get a nice loud effect off of that speaker there. Oh, have I broken it? Come back. And I don't have it here. I don't know if he wants me to play it or not, but when I first got the code from Phil B, he cracked me up because he had taken, he needed sound effects to test with, and so he just did them with his mouth. He just went, and it's hilarious. If he'll let me, I'll include those sound effects, because hearing this sword have the sounds made by a guy just making the sounds, it actually sounds fantastic and cracks me up. So thanks to Phil B for that. So questions from the chat in Discord. Yannick asks, what's the advantage of using NeoPixels over dot stars, for example? I don't know that there's an advantage of using NeoPixels over dot stars other than they are less expensive. If you are interested in doing a higher end build, you may want to go with dot stars in case you're doing like faster refreshes or things like that. Or if you want the greatest density possible, I think we have some pretty small 144 dot star per meter. I don't know if we may have NeoPixels that dense as well. The other thing you'll notice is, let me put my little tent back up here. Actually, I'm gonna assemble the, let's see, is that NeoPixel? I don't want to get those wrong. I'm going to reassemble the blue one here so that you can see it under the little tent. What have I done? Is that in the right place? No, it's not. So NeoPixels and the sensors both have 3 pins. It's not going to hurt anything to plug them in wrong like I did there. There we go. So let me show you one of the nice things about using this coroplast is that it kind of, besides diffusing the light, it kind of reflects the light internally. It kind of bounces around inside of the tube guard a bit. Enough so that we get quite a bit of light on the back side of the sword. So it's not just where it's facing front, which is nice. So let me switch you to this camera view. That's the big one. So you'll see it's actually pretty nice on all sides. You can see as I am shaking it here, it's changing colors. So it's not perfect, and you can see there's a little edge. There we go. There's a little edge there of the coroplast you might notice. But not terrible. Now, that's just with a single strip. What some people will do is they'll face strips in both directions so that they get brightness on all sides. That's another way you could do it. I actually kind of like the way the back side of this looks because I definitely don't see any individual dots. You can still see some of them there, especially under the camera. Oops. On the front side. So actually facing this way is more uniform. So I could possibly use more diffusion or more coroplast on this side to reduce that further. But not bad for just honestly a few dollars worth of parts there. The plastic, the tube, the coroplast, the parchment paper. It's all relatively inexpensive stuff for making what I think is a nice looking lightsaber. So let's see if that, I think, takes care of everything with the build. We got any other questions? Let's see. I'm going to run over to the workstation and see if we got any last questions before we wrap it up. So let's see. I'm going to switch cameras here. Hello again. And hey, look, there's my cool sine wave thing again. So how long the battery would last, I don't know. I haven't done the calculation on it. I'm using a 500 milliamp hour LiPo. It's a 3.7 volt LiPo. And I will try to run the calculations on that. One thing about the NeoPixels is that we have a rule of thumb that they draw, I think, 60 milliamps per pixel. And that's 30 pixels. However, the 60 is, I believe, when you consider running 3 colors on them, RG and B. So really on that one I'm running 100% blue and I think maybe 50% green or less. So it's going to be lower. If you use single colors, you're using like a third of the juice. So that's important to remember. The rainbow one is going to probably use more power because some of those colors are mixes of 2 or even 3 of the LEDs built into the NeoPixel. Let's see. Mr. Certainly says, with all the HalloWing's exposed wires, it'd go well with Kylo Ren's crossguard lightsaber. Absolutely, that would be very cool. Someone should make one of those. I'd love to see that. Yes, so the effects, for the most part, are actually all the effects that you heard there now are free public domain sound effects that I got on freesound.org. It's a great place to go check out sound effects, and those will be included with the link because they are sort of free and Creative Commons licensed to use. Let's see. I wanted to make my own. I was getting ready to fire up some synthesizers and try to make my own sound effects, but I was running out of time, so I found some good ones. So let's see. Hawk 3D Proto said that I think it wants to know if there's going to be a video on the step-by-step build. I took photos of the build doing both of these that are going to be in the guide, so I won't have a video of that, but you'll have all the pictures that you could want. 80-something pictures I think I took of the build there. And I'll give a little bit of a teaser, which is I believe the Ruiz brothers are going to be working on a high-end lightsaber build sometime in the future. So 3D printed parts and everything maxed out and 50 bazillion NeoPixels. So watch for that. That's going to be awesome. But this one, if you pick up a HalloWing, this is definitely a build that you could do quite quickly in case you're going as some sort of a Jedi or a unicorn. That's what we're calling the our pink, or rainbow rather, build here. That's our unicorn build. Angels sing. All right. So I think that's it. So let me just say before I go that you can use the coupon code to get your 10% off in the store. Go pick up some parts and build yourself a lightsaber. So thank you all for coming out. I'll hang out in the chat for a little while on Discord if you want to continue the discussion. And I want to thank you all so much for stopping by. This has been John Park's Workshop on Adafruit. Bye-bye, everyone.